in this video we're going to look at what's called literal equations. But before we do that, let's go ahead and start with these three problems. Kind of reviewing what we've been working on in this unit, which is solving linear equations and inequalities. Take a few minutes and see if you can try these three problems. Okay, so number one here, we've got a linear equation, and a lot of different ways to do it. This is not the only way, but one of the ways is to go ahead and subtract 1 on both sides. So I'm going to do that over here. So subtract 1 on both sides, and we're going to get 3/4 x plus 2 equals 7x minus 5 now. And then we can distribute the 3/4 in here. So 3/4 times x would be 3/4 x. 3/4 times 2 would be 6/4 or 3/2. Okay, so from there we can isolate x. So let's see. Let's go ahead and this is 1.5. So if we subtract 1.5 from both sides, we're going to get 3/4 x equals 7x minus 6.5. From there, let's see, we can subtract 7x. So it's going to be negative 6.25x equals negative 6.5. And it's okay, we're dealing with fractions, we're dealing with decimals, it's okay. Our answer is not going to be a nice integer in this case. We're going to get something a little bit less than, or a little bit over 1. Let's see, let's take out our calculator here. 6.5 divided by 6.25 and 1.04. So 1.04 is hopefully what you got there. All right, if you want to check our answer here, we can always substitute that back in to our original here, 1.04 here and 1.04 there, and just double check that we get the same value out. Number two, really to reiterate the idea when we multiply or divide by negative, I created this problem here. So we have negative 3x, well, let's go ahead and subtract 1 on both sides. So we get negative 3x is less than 12. To get x by itself, we're going to divide by negative 3. We're going to divide by negative 3. But anytime we do that, anytime we divide by negative 3, or any negative number, anytime we multiply or divide by a negative number, we're going to have x is greater than, remember we always change the sign because that relationship between our two values change. And we're going to get to negative 4. Okay? So let's just test the number. So how about x is greater than negative 4, so like negative 3, negative 2, something like that. Let's try negative 2. We put a negative 2 here. Negative 2 times negative 3 is positive 6. Positive 6 plus 1 is 7. Is 7 less than 13? Yes. So negative 2 worked, and that's just kind of how we can kind of check some values there. Number 3, how many solutions do these equations have? Let's talk about these three right here. This one will have no solutions. Going back to that idea that this one has a slope, I know it's in reverse order, but this one has a slope of 3 and a y-intercept of negative 7. This one has a slope of 3 but a y-intercept of 4. So because their slopes are the same, but they have different y-intercepts, they're going to be parallel, meaning they never touch, right? If you draw the two lines. Down here, these two have the same slope and the same y-intercept, meaning they are the same line. Therefore, there are an infinite number of solutions. And then lastly here, if they have different slopes and different y-intercepts, really if that's the case, then it's just going to have one solution, meaning they're gonna cross and intersect at one point. So no solution, infinite solutions, and one solution. All right, so again, our goal for today is to rearrange formulas, sometimes called literal equations, to isolate a quantity of interest using algebraic reasoning. So we're going to use the same idea that we've been using to solve linear equations to rewrite formulas or literal equations in a way that isolates a particular variable. All right, so let's go ahead and get into it. So and this is kind of off the screen here, so let me move it back over here. All right, so we have a rectangle here. We have the width and the length, and we want to calculate the perimeter. So the perimeter is the length all the way around. So we have two widths, so this is the width as well, right? So two widths, so W plus L plus, this is also the length, right, L. So you have 2L plus 2W, and that gives us our formula here for perimeter. But what we're going to do today is rewrite these equations to isolate a different variable. So we could isolate the width or the length instead of the perimeter. Right now the perimeter is isolated. So we can calculate the perimeter really easily by substituting in values for the length and width. But what if we've got the perimeter and we've got the width and we want to calculate the length? So can we come up with a formula that produces the length given the perimeter and width? Well, let's see. We want to isolate the length, and so we want to solve for L, just like we've been solving for X or M or whatever variables we've been working with. Same reasoning here, we're going to solve for L. All right, so whatever we do to the left side, we've got to do to the right side, just as we've been doing. So let's start out by subtracting 2W from both sides. Okay, on the right side, when we subtract 2W minus 2W, we get nothing here, 0. So it's going to be 2L is all we're left with there. On the right side, we are going to have P minus 2W. We cannot combine those together. Those are not what we call like terms. All right, it's like adding apples and oranges. All right, we can't do that. So P minus 2W is just P minus 2W. And then the last thing we're going to do is divide by 2. Just remember, we have to divide the whole right side by 2 and the whole left side by 2. So when we divide the right side by 2, it's just going to be L. When we divide the whole left side by 2, we're going to get P minus 2W divided by 2. Okay? So this is one way to write this. I'm going to show you one more way. Both are great ways to write it, but just so you know that this is an equivalent form here. If we went ahead and divide each of these by 2, right, P divided by 2 would be P over 2 minus 2W divided by 2. 2 divided by 2 is just 1, so it'd just be minus W. So both of these versions work. I just want you to know that both of those are describing the same values here. So L could equal this, or L could equal that as well. So that's the idea that we're getting into today, is rewriting either formulas or literal equations for variables that are not currently isolated. So now what we could do here is we could calculate L really quickly by substituting in the perimeter and the width. I do this a lot of times with Excel. If I want to create a column over here that calculates something given a couple variables over here, but it's not currently in the right form, I'll rewrite it in a different form like this, so I can calculate L really quickly, so I can have a column for the perimeter, a column for the width, and then a formula that calculates the length given the perimeter and width. So I do this quite a bit in Excel and things like that. All right, let's move on to our next one. So we got the circumference of a circle. So the circumference of a circle is this length all the way around here in the circle. And the circumference is given by two different ways you can think about it. Remember that the radius is just from the center of the circle to the circle itself, and then the diameter is from one side all the way across to the other, but through the center. So the diameter is actually twice the radius. That's gonna be a really important idea. The diameter is twice the radius. So one formula that you might see is circumference is equal to 2 pi r. So 2 pi r. But notice, what do we have here? We have 2r, twice the radius. So we could instead write the circumference as pi d. So pi times the diameter. So these are both ways of getting the circumference. If you've got the radius, then maybe use this formula. If you've got the diameter, then you can use this formula. Whichever one is easiest based on what information you're given. But what if we were given the circumference and we wanted to find the radius or the diameter? We might want to come up with a formula for that. So where we isolate r or we isolate d. So let's solve for r here and then d over here and come up with those formulas. So with r here, by the way, pi, hopefully you've heard of pi before. Pi is an irrational number, meaning it never ends or repeats. It is still a finite number. It's not infinitely large in terms of its value, but the decimal goes on infinitely, if that makes sense. So it's approximately 3.14159, and it's the ratio between the circumference and the diameter, as you see right here. It's that ratio there. Anyways, let's go ahead and solve for r. It's just a number. So 2 pi itself is just a number, about 6.28. So 2 pi is just a number, is what it comes down to. So if we want to solve for r here, we're going to divide both sides by 2 pi. So we get r equals circumference over 2 pi. And now we've got a formula. All right, if I've got the circumference, how do I get the radius? Oh, I divided by 2 pi, and now I've got the radius. And the same thing over here. I can divide both sides by pi, and that's going to give me circumference over pi equals diameter. Okay, so now I've got a formula. If I've got the circumference, how do I get the diameter? I just divide by pi. All right. So let's see. Our next one here is going to be a little bit more involved because I need to kind of show you why this formula is the way it is first. But we're talking about the interior sum formula. All right, and the interior sum is like the sum or the adding up of or the total angles involved in a polygon here. So let's start with a triangle. In this case, this is what we call an isosceles triangle, in which 2 of the sides are congruent. Anyways, what we're going to do is we're going to think about this angle plus this angle plus this angle. You've probably heard this before. The sum of the interior angles in a triangle is 180. So if we add these 3 angles up, we get 180. If not, we're going to actually look at this later in integrated math 1 and see why that is. But a triangle adds up to 180. So what we can do is we can actually take a quadrilateral, which is 4 sides, a pentagon, which is 5, hexagon, which is 6, a heptagon, 7, and octagon 8. And we can actually break it up into triangles. So if we take a quadrilateral and we draw the diagonal, it actually separates it into 2 triangles. And so we know that, let's see, these 3 add up to 180, right? And these 3 add up to 180. So these 2 angles are the angles themselves, but then these 2 add up to be this whole angle, these 2 add up to be that whole angle. So altogether, those 6 angles are equivalent to the 4 big angles. So therefore, if this is 180 and this is 180, then when we have 4 sides, it's going to be 2 times 180. You'll see that, right? 2 times, because we have 2 triangles, times 180. 3 sides was just 180, right? Okay. How about 5 sides? Okay, if we have 5 sides here, we can draw a line there, and then now we've got 3 triangles in there. So we've got 3 times 180 for the same reason as we did here. So for 5 sides, we have 3 times 180. 6 sides, let's see, we can draw 1, 2, 3, 4 triangles. So we have 4 times 180. Let's see, heptagon, 1, 2, 3, 4, 5. So 7-sided figure polygon, we have 5 times 180. And then lastly, 8 is 6 triangles in there, so 6 times 180 altogether. So we want to think about how many sides. Let's see, if we had n sides. So can we generalize it to be any sided figure? Can we calculate how many, or what the sum would be? All right, well, let's see if we can find a pattern here. 3 is 1 times 180. 4 is 2 times 180. 5 is 3 times 180. Okay, let's see. What's the relationship between the number of sides and the multiple of 180? Well, if you notice, the multiple of 180 here is always 2 less than the side number. So if we take the side number, when we subtract 2 and multiply it by 180, that's going to give us our formula for the sum of the interior angles. All right, now we could technically distribute the 180 here if we wanted to. See, 180 times n would be 180 n, and then 180 minus times -2 would be negative 360. So that would be an equivalent form of that. We're going to mainly refer to this one here because this one's a little bit more difficult to calculate if you're given the side numbers. Here you can just subtract by 2 really quickly and then multiply by 180. It's a little bit less involved there. So that's our formula for the sum of the interior angle sum. So we have S, which stands for sum. The sum of the interior angles of a polygon equals 180 times the side number minus 2. So n is the number of sides minus 2. Okay, so this would be really great if we had the number of sides. So let's say we had a 10-sided figure, and we wanted to figure out what's the sum of the interior angles. We could calculate that really quickly. But what if we had the sum and we wanted to find the number of sides involved, the number of sides in our polygon? And let's say we wanted to figure that out really quickly and make an Excel sheet to write all this out and calculate it for us. Well, we would need a formula that would give us the sum given the number of sides. And so we want to solve for n, or isolate n, as we've been doing with some other examples here. So let's get n by itself. Okay? So the first thing we're going to do is we're going to do the inverse operations in the opposite order. So opposite order in terms of the order of operation. So inverse operation would be to divide by 180. All right? So we divide both sides by 180. So we have S divided by 180 equals n minus 2. And the last thing we can do is add 2. So S divided by 180, and then we're going to add 2 to both sides. So S divided by 180 plus 2 equals n. Or n, I'm just going to switch the order here. S over 180 plus 2. So now we got a formula. We can take the total interior angle sum, divide by 180, and then add 2, and now we've got a formula to produce the number of sides given the angle sum. All right, up next, area of a pentagon. Area of a pentagon is an interesting one. It's defined as P, so P stands for the area of the pentagon, equals 5/2 times S times A. S is the side length, and A is what's called the apothem, and it's really just from the center of the pentagon down perpendicular to one of the sides, in this case the bottom side. But it says, what is the formula in terms of S? So when we say in terms of S, that means isolate S. So get S by itself. So let's see if we can get S by itself here. Let me give you a minute to try this one and see what you can do. Okay, so in this case, we have P equals 5/2 SA. All right, so if we want to get S by itself, we need to, got a number of ways to do this. Let's multiply both sides by 2/5. I'm going to do this in a different color here. 2/5. 2/5. So we're going to get 2/5 P equals 2/5 times 5/2. The 5 divided by 5 is 1, 2 divided by 2 is 1, and we're just left with S times A. Last thing we need to do to get S by itself is to divide by A. Again, inverse operations in the opposite order. So divide by A, we're going to divide by A. So it's going to give us S is equal to, and there's a number of ways you can write this. You can write it as 2P divided by, since we're dividing by A here, really we can think about it as going in the denominator here. So it'd be 2P divided by 5A is one way to write that. So now what we have is, if we know the area of the pentagon and we know the apothem, we can actually find the side length. So we've rewritten this formula to isolate the side length. All right, let's go on to another one. Oh, here's a good one. So Fahrenheit, if you want to convert from Celsius to Fahrenheit, so converting from Celsius to Fahrenheit, you would take the temperature in Celsius, multiply it by 9/5, then add 32, and that would give you the Fahrenheit. But what if we wanted kind of the opposite, where we want to convert from Fahrenheit to Celsius? We couldn't really use this formula directly, at least. We need to create a different one. So let's solve for C. So take a minute and see if you can solve for C, which is the temperature in Celsius. Okay, so in this case, we're going to, again, inverse operations in the opposite order. So normally we would multiply first and then add, right, according to the order of operations. But in this, when we were solving or isolating a variable, we do the inverse operations in the opposite order. So we're going to subtract 32 from both sides. So we have F minus 32 equals 9/5 C. And then 32 minus 32 is just 0. And then from there, we can multiply both sides by the reciprocal, as we did in the last example. The reciprocal which would be 5/9 on both sides. 5/9 on both sides. So then when we multiply that out, we're going to get, we'll just leave that alone here, 5/9 times F minus 32 equals 5 divided by 5 is 1, 9 divided by 9 is 1, so it's just equal to C. So what we would do here is we would take the Fahrenheit value, subtract 32 from it, and then multiply by 5/9, and that would convert it into a temperature in Celsius. And so, again, we're just isolating a different variable by using the same reasoning when we solve an equation. We're just, there's just going to be some letters involved as you solve for that letter, or for a different letter. Okay, last one here. A company uses 2 different size trucks to deliver sand. The first truck can transport X cubic yards and the second Y cubic yards. The first truck makes 5 trips to a job site while the second truck makes 7 trips. The total amount of sand delivered was 43 cubic yards. Write an equation to represent this situation. All right, so we have the first truck can transport X cubic yards and it made 5 trips. So it transported X cubic yards 5 times, in other words. So how much sand did it transport? Well, X cubic yards 5 times, that would be 5X. So the first truck transported 5X cubic yards of sand. The second truck carried Y cubic yards 7 times. So that would be 7Y. Right? 7 trips, Y cubic yards each time. So 7Y is the total number of sand the second truck carried. So together, if we added 5X and 7Y, that would give us the total amount of sand involved or being delivered. So if we add these together, we get the total amount of sand that's been delivered, which is 43. Right? So since this represents the total amount of sand delivered, we know that that's equal to 43. So now we actually have an equation here that we can work with. So this is the equation that they asked us to write. And now what I want you to do is see if you can isolate Y. So see if you can isolate the number of cubic yards that the second truck carried. So get Y by itself, isolate Y. All right, so if you do that, you're going to first subtract 5X. So we 7Y, well, let me go ahead and write it out here. So minus 5X on both sides. So you have 0 plus 7Y equals 43 minus 5X. And then we're going to divide by 7 to get Y by itself. So divide by 7 on both sides. And you're going to get 43 minus 5X over 7. So this is one version of it that you could have. Again, you could divide both of the terms by 7 if you wanted to. 43 divided by 7 minus 5 divided by 7x. And that x, this x could be, it could be 5x over 7, or it could be 5/7 x. Either way is fine, right? This is x over 1, so if you multiply the two fractions together, you're going to get 5x over 7 times 1, which is that. So they're both equivalent. Either way you want to write it is fine. So now we've isolated y, and now we can calculate however many, if we know the number of trips that, or number of cubic yards that the first truck took, then we can calculate the number of cubic yards that the second truck took each time. All right, so this idea of solving literal equations, isolating a variable, using the same reasoning as we did with solving equations, and that was our goal for today. All right, so hopefully you'll join us in our next video in this Integrated Math 1